INFINIDAT, the standard in enterprise storage. Experience faster applications, zero downtime, built-in cyber resilience, and massive savings. Let's start with INFINIDAT's performance results in the real world. In the real world, latency matters, and latency enables results. INFINIDAT, perhaps the best kept secret in the storage industry. Over the past decade, the company has quietly delivered some of the most performant, reliable storage that you can buy to serve the needs of high capacity, high performance, mission critical workload. But the secret is out. Steve McDowell, More Insights and Strategy, August 2022. INFINIDAT has literally changed the way we see and invest in storage today. 60% TCO reduction, dramatic improvement in management simplicity with both availability and performance guarantees. Oracle backups have been taking 48 hours to run, now run in 8 hours on INFINIDAT. These results are driven by performance and in particular latency. But let's look at hero numbers from vendors versus performance numbers in the real world. So let's be open, honest, and realistic about performance and talk about performance in the real world and what that really means. And what really matters the most in performance in the world of storage is latency. Latency helps your applications perform better. Latency is really measured in two contexts, the internal latency versus the total latency. And let's take a look at that. If you take an example of a server with some sort of network connection and a storage array with a network connection, whether that's fiber channel or Ethernet is immaterial, with some network in between. The whole concept here is that server to request some data that's on the storage array and deliver that data to that server. Well, if we look first at internal latency, that's the time it takes for that data to be delivered and prepared inside the storage array. It takes the request at the edge of the storage array, prepare the data, and bring that data to the edge of the storage array. Server doesn't have it yet, hasn't been passed through the network. That's internal latency. By the way, that's what most vendors communicate when they talk about their latency. Now let's look at total latency. And total latency is the time it takes for that server to say, I need a block of data, put that request over the network into the storage array prepare its data, and deliver that data to the edge of the storage array, across the network, and over to the server. That's adding in the overall network latency. That's latency in the real world. Now, when we show in our presentations and our tools from INFINIDAT, we are providing the storage latency from the world of the storage array. And at the world of the storage array, we can deliver that I/O all the way across to that server. But when we show you our performance numbers, of course, we will show you the internal. But when we talk about total latency, because we're taking it from the concept of the storage array, we do not know the amount of time it takes from the server to request the data to the storage array. We're just going to give you the point here where it enters the storage array to prepare the data and deliver that all the way to the server and acknowledge that request from the server. So it's almost total latency. Now, in that spirit of let's be honest, open, and realistic about performance, let's first look at what hero numbers are from a vendor, in particular in the context of latency. When a vendor publishes their hero numbers, air quotes, what that typically means is an I/O of 4K size, in other words, small block I/Os. It typically means a test in which there was one server connected to one storage array. That I/O request is done with a 0 storage queue depth, and there's absolutely nothing else running on that storage array. And it is a measure of the internal latency, not round trip or total latency. That's latency in a perfect world. Well, let's look at real world performance and real world latency. And typically latency in the real world is using a block size of 32 to 64K or large blocks. That's what most applications use. It typically means there are many servers connected to this storage array, operating many different applications all at the same time. And those servers are using an optimized storage queue depth, and you're showing total latency, the latency it takes from the server all the way to the storage array and back. That's latency in an imperfect world. And that imperfect world really is the real world. Now, in fact, INFINIDAT can demonstrate 35 microseconds internal latency in the perfect world as well as the real world. So let's look at some real-world examples of INFINIDAT customers and those arrays performing in the real world. These are real customers running real systems, running real workloads, getting real results. The first system we'll look at is from a large health insurance provider. It's one of our InfiniBox SSA all-flash arrays. It's one of our first-generation all-flash arrays that has over a 1.3 petabytes of physical capacity running encryption. It's fiber channel attached to 47 physical hosts, all running VMware in 10 clusters. It's 100% virtualized, and in the VMs running either Red Hat Enterprise Linux or Windows Server, and running databases like Oracle, DB2, Tableau, and SQL Server. And in the real world, its performance is actually a mix of small and large block IOs. From a read perspective, 50% of the read IOs are less than 32K block size, and 60% of the write are less than 32K block size. So let's take a look about how it performs in the real world. This system, you can see the workload increased back in the July timeframe pretty significantly, so clearly added more workload over that time. But since that time, you see the workload is very, very similar and very, very consistent performance. And then as we look into each quarter, the past quarter, you can see the workload is very consistent over time. As we look at the month, again, very consistent. As we drill into a week, now we can see that it's very, very consistent each day. And you can see in the start of each day, there's a peak of workload. Let's look at the 28th. And we can see at the start of each day, there clearly is some sort of workload that happens as a spike. But let's take a look at that particular day and drill into a bit more time frame in here. And we can see that the latency, as we look over here to the right, remember that latency is measured in milliseconds. So in this particular point in time, we see 0.04 internal read latency, which is 40 microseconds. So I'm going to state everything in microseconds. So very, very consistent performance. Even in total latency of 120 microseconds, we're hitting those internal latency in the sub 100 microseconds very, very consistently. Now that's indicative of this system, of its neural cache having a very, very high hit ratio, up into the high 80s, 90s very consistently. But even when there's times when there is a pretty low hit ratio, down in the 79 or 78, or down in a 42%, you can see that our latency still is in the 200 microsecond range. So indicative of what the neural cache can do, or even our backend can do to deliver very consistent performance. Now in this environment for this customer, again, very large block IOs because it's a VMware, Oracle, DB2, SQL Server environment. Again, real-world environment, multi-applications, multi-servers, connected, leveraging our platform. 93% of the IOs are large block 32K or greater. 75% of the write IOs are, again, large block 32K or greater. So very impressive performance, leveraging our neural cache, or even when our neural cache has a miss, the performance is still incredible. Now let's look at another large health insurance provider running one of our second generation's InfiniBox SSAs, or all-flash array. It has over a petabyte of physical capacity. It's getting about 2.1 to 1 compression, has encryption and FIPS certification turned on as well. It is connected via iSCSI to over 215 physical hosts, all running VMware, with Red Hat Enterprise Linux and Windows servers in the VMs, and running Oracle and SQL Server, as well as some custom apps in their CRM system. Now, its real-world performance is mostly large block IOs. 85% of those large block read IOs are 32K or larger. 60% of the IOs are 32K or larger. So let's take a look at how this system is performing in the real world. Deployed in July of 2022, and workload steadily increased onto this system until around October where it settled in. Remember, this is one of our InfiniBox SSAs, one of our second generation all-flash arrays. And it is running an environment as 100% virtualized in VMware, running Red Hat Linux and Windows. And primarily the applications are Oracle and SQL Server-based applications, and primarily running a CRM and some custom apps. Now the I/O profile here is, for the read, is 85% of the reads are 32K block sizes or larger, and 60% of the writes are 32K block size or larger. So in other words, it's a large block I/O system. Now you can see if we look for the year, let's drill into the workload for the quarter, and we can see it's pretty consistent performance once after October started of read and write profiles. We look into a month. Again, very similar with spikes each day. You can start to see a couple spikes each day, which we'll see in a week here. When we look at our week view, that we can see that that's typically Saturday and Sunday. There's extra workload happening at the start of each week, Saturday and Sunday. Let's look and drill into one of the days. Let's look at the 28th. And as we look in here, we see a pretty steady I/O profile, very consistently of almost 300,000 IOPS, 200 to 300,000 IOPS, very consistently over the course of the day. Now let's look at our latency here as we look down below. And remember, latency in our system here is expressed in milliseconds. So as we look down in here and see internal latency of 0.19 milliseconds, which is 190 microsecond latency, as we see in here, latency internally is somewhere in the mid-hundreds to 200 latency. Remember, this is big block I/O. And then you can see the latency from a total perspective, which is the round trip back to the server, is around 200 microseconds. A little bit of spikes here and there, but very, very consistent performance over the course of the day. And remember, this is large block I/Os. Now, what's pretty impressive in this system, as we look into our neural cache and our read cache performance, the neural cache hit ratio sometimes is 50%, 53, sometimes spikes up into 70 or 80. So what that's showing you is that the workload in this system is incredibly random and very unpredictable. But we're still getting that incredibly low latency of what we see up in the top, up into the high 100 to low 200 microsecond latency, which is incredibly impressive. Now let's look at a system from a large telecommunications company. It's one of our InfiniBox second generation hybrid systems. It has over a petabyte of capacity with encryption turned on. And it is connected via fiber channel to 35 physical hosts that are running either Red Hat Enterprise Linux or IBM AIX. And it has a custom app that's for a major cell phone grid, and they have their business analytics system on it. Now, in the real-world performance of that system, it has very large block size. What I mean by that is 85% of all IOs are greater than 64K block size. 70% of write IOs are greater than 64K block size. Now, if I actually look at that, most of those IOs are actually greater than 512K. So very, very large block size. And let's take a look at its performance. I think you'll see this hybrid system's performance will give similar or better performance than most all-flash arrays on the market today. Let's take a look. We can see in the April-May timeframe here, up in the IOPS, that the write profile became much more prevalent than the read profile. Remember, this system is one of our InfiniBox hybrid arrays connected to many bare metal servers running Linux or AIX and a custom application from the customer. Now, what's unique about this is all IOs are very, very prevalent in very large block sizes. In fact, 85% of the read IOs are greater than 64K block size, and greater than 70% of the write IOs are greater than 64K block size. In fact, in both of those scenarios, 512K block size is most of the IOs. So let's look at that profile and drill in and get a little more details on it. As we look at the quarter, the past quarter, we can see quite a bit of write IO. As we look into the month, we see that write going up and down over the course of each day with pretty consistent read I/O. Now let's look into the week. We can start to see these trends. Now as we look at a particular day, let's look into the 28th and just drill into it a bit and see the I/O profile over the course of the day. You can see the write is very, very consistent as a majority portion of the I/Os with little peaks of reads. Well, let's look at the latency. Now as we look down below, latency here is always measured for us in milliseconds. And as we look in that in the area of milliseconds, 0.06 read internal latency is 60 microseconds. So remember, very, very large block sizes. Our read internal latency, as we scroll across here, you can see very consistently in the high tens of microseconds to low 100s of microseconds, peaking up into 200. Remember, very large block sizes. As we look and scroll across, very consistently, low 100 microseconds from a read. If you look at total latency, also pretty impressive total latency for read and write. Now remember, those latencies, as we look in that level of 100 microsecond type latency from internal, remember those hero numbers from our competitors, that's better than most all-flash array on the market's hero numbers. This is a hybrid array from INFINIDAT, our InfiniBox, in production with a real-world workload. Well, you may say, well, how do we do what we do? Well, let's look down here about our neural cache. If you look at this system, because it is a hybrid array, our neural cache consists of our DRAM as well as our SSD backed up DRAM cache as a supplement to it. As we look at that, is our cache hit ratio is very consistently, add those two numbers together, 95 and 4.5, is we're talking almost 100% neural cache hit ratio. That's how we're getting that impressive latency. So what does this all mean? It means INFINIDAT delivers in the real world. More physical, more virtual servers, running more applications, delivering more results to the business. So what does it all mean? It means your applications can run better. SQL Server and a monthly and reporting solution improve performance by 10x, reduce the rack space by 4 times, while materially decreasing latency and increasing write throughput. Oracle, that 100% neural cache hit ratio, delivered 40 microsecond latency across the entire array. SAP queries reduced from 120 hours to 20 minutes, and the VMware performance increased by over 30%. In Elastic, queries that took 40 minutes to execute now take 15 minutes on INFINIDAT. That's a 3 billion records per day ELK environment. In SPLUNK, in a real-time machine learning application for threat detection, they process 1 million security events per day and have 61 billion events logged. INFINIDAT enabled 7 million in CapEx savings. Applications run better on INFINIDAT. INFINIDAT, guaranteed to deliver on your SLAs. Comprehensive guarantees for performance, availability, and cyber recoverability set the standard for enterprise storage. Thank you.